Hello, welcome to Computer Education for All. Today's topic:
data communication, network communication component, modes of network communication, communication devices, network architecture, types and characteristics of networks, network topologies, data communication standard, the Internet. Let's start.
Data communication. Data communication refers to the process of exchanging data or information through a computer network between two or more devices or systems through a transmission medium such as cables, optical fibers, or wireless mediums. This communication can involve the transfer of various types of data, including text, numbers, images, audio, and video, and it is a fundamental component of modern information technology and telecommunications. A simple communication network having wired and wireless connections is shown in Fig. 1.44. Network communication components. Data communication is the process of transferring information from one point to another in a networking environment. Network communication consists of 5 basic components, as shown as Fig. 1.45. Sender, message, medium, protocol, receiver. Sender, also called transmitter, is a computer/device that sends the message, data, or information from source to destination in a communication network. It may be a computer, workstation, cell phone, or camera. The sender device converts the electrical signal into a form that is suitable for transmission over the communication network. Message. Message is the data or information that is to be transmitted. Message can be in the form of text, audio, video, or any combination of these. Medium. Medium is the path through which message travels from source to destination. A medium can be wired, for example, telephone cable, coaxial cable, and fiber optics. It can also be wireless, for example, Bluetooth, Wi-Fi, microwave, radio wave, and satellite. Receiver. Receiver is the device which receives transmitted message. It can be a computer, workstation, telephone handset, or television set. The data received from the transmission medium may not be in proper form to be accepted to the receiver, and it must be converted to appropriate form before it is received. Protocol. A protocol is a set of rules that governs data communications. It represents an agreement between the communicating devices. Without a protocol, two devices are connected but may not communicating with each other. Modes of network communication. Modes of network communication refer to the methods or the ways information is transmitted from one place to another. The following are different modes of data communication: simplex, half-duplex, and full-duplex, synchronous and asynchronous. Simplex mode. In simplex mode, the communication takes place in only one direction. In this mode, communication is unidirectional. The communication can only take place in one direction, and it is not possible for the receiver to send data back. For example, data is sent to an electronic notice board found in train stations and airports, as shown in Fig. 1.46. Radio and television broadcastings are also examples of simplex transmission. Half-duplex mode. In half-duplex mode, the communication takes place in both directions, but not at the same time. The signal can only be sent or received at one time. A common example of this type of communication is the use of walkie-talkies as sender/receiver, shown in Fig. 1.47, where each of the persons communicating must indicate when they have finished speaking. Half-duplex transmission is used also in transaction-oriented systems, for example, communication between a computer and a credit card machine. full-duplex mode. In full-duplex mode, the communication takes place in both the directions at the same time. In this mode, both sender and receiver can send and receive the data simultaneously. For example, when two computers communicate with each other to send and receive some data, as shown in Fig. 1.48. It is the fastest bidirectional mode of communication. The full-duplex mode is like a two-way street, with traffic flowing in both directions at the same time. One common example of full-duplex communication is the telephone network. When two people are communicating by a telephone line, both can talk and listen at the same time. Asynchronous transmission. In asynchronous transmission, the time interval between two characters is variable and not fixed as shown in Fig. 1.49. The computer devices can exchange information at their own rate, slow or fast. Start and stop bits are used in asynchronous transmission. These bits provide timing, synchronization, for the connection between the sender and the receiver. The start bit tells the receiver that a character is coming, and stop bit indicates that the transmission of character has ended. This type of transmission is ideal for slow-speed communication when gaps may occur during transmission. Example of asynchronous transmission is keyboard data transmission. Synchronous transmission. In synchronous transmission, the time interval between two characters is always the same as shown in Fig. 1.50. In this method, two communicating devices are synchronized, and they continue to send characters in order to remain synchronized, even if there is no data to be transmitted. A special idle character is sent when there is no data for transmission. It does not require transmission of start and stop bits. It sends data as one long bit stream or block of data, and each bit is sent one after the other. The receiver counts the bits and reconstructs the sent information in bytes. It is essential that timing is maintained, as there are no start and stop bits and no gaps. Accuracy dependent on the receiver keeping an accurate count of the bits as they come in. Synchronous transmission is faster than asynchronous because fewer bits have to be transmitted, i.e., only data bits and no extra control bits are sent. The best example of synchronous transmission is the data transmission between devices in network communications links. Communication devices. A device that is used in telecommunication systems for transmitting data from one location to another is known as communication device. Commonly used communication devices are hub, switch, router, and gateway. Hub is a connectivity device used in LAN. It connects multiple LAN devices on one network and makes them act together as a single network. A hub is a non-intelligent device and sends output to all the devices on the network. A hub has multiple input/output, I/OA ports, in which an input in one port results in it being an output in all the other ports, except the port where it was input. A hub is shown in Fig. 1.51. Switch is a networking device that performs the same job as the hub, but are considered as intelligent than hub. It gathers information about the data packet and forwards it to only the node, e.g., computer it was intended for. A data packet is a basic unit of communication over a computer network. When data is transmitted, it is broken down into packets, which are reassembled to the original form once they reach the destination. A switch is shown in Fig. 1.52. Router is a communication device which is used to connect two or more networks. Today, most of the networks are connected to Internet. When the computer is sending data to another computer on the Internet, router receives the data packets, looks for the remote computer address, and forwards it to a computer that is closer to the remote computer. It forwards the data packets by selecting the best pathway based on network traffic. Many routers take part in transmitting the data packets from one location to another. A wireless router is shown in Fig. 1.53. Gateway. Gateway is a device that is used to connect a network to another network that uses different protocols. If we have to link different kinds of networks, such as a network of IBM mainframe computers and a network of Cs, we might have to use a gateway. Gateways change the format of the data packets, but not the contents of the message, to make it conform to the application program of the remote computer. A gateway is shown in Fig. 1.54. Network architecture. Network architecture is the design of a communication system. It includes hardware devices, such as routers and switches, cabling, network topology, and physical and wireless connections. Computer networks consist of server computers and client computers. Server computer, a computer on the network that shares resources for others to use, is called a server computer or simply server. Shared resources include information, software, printer, plotter, internet connection, hard disk, etc. Client computer, a computer on the network that accesses resources that are shared by other computers, is known as client computer or simply client. The two commonly used network architectures are client/server network, peer-to-peer network, client/server network. A computer network in which each computer on the network acts as either a server or a client is called client/server or dedicated server network. Each server computer on the network is called a dedicated server. Servers are not used as client computers. Fig. 1.55 illustrates how a dedicated server network may be designed. The computer at the top of the figure is the dedicated server, sharing files and applications. The remaining computers in the illustration are clients that access resources shared by the server. Similarly, in a dedicated server network, client computers never act as servers. Client/server network includes one or more computers that are dedicated to acting as servers. The servers are optimized to provide quick access to shared network resources. Servers also provide centralized security to ensure that resources are not accessed by unauthorized users. Because the client/server approach centralizes control of data and other shared resources, one person or group is typically responsible for administering the network. Peer-to-peer networks. In peer-to-peer networks, every computer is capable of playing the role of client, server, or both at the same time. In this network, each computer on the network is referred to as peer. In a peer-to-peer network, a peer computer can act as both a server and a client at the same time. A peer computer on your desktop can share files and printers with other computers, and it can simultaneously access other shared resources on the network. A conceptual view of a peer-to-peer network is shown in Fig. 1.56. Peer-to-peer networks tend to be relatively small. Most of these networks fall to range between 2 and 10 computers. Large peer-to-peer networks become difficult to manage because so many network administrators control sharing and maintaining shared resources. Types of networks. The following are different types of networks based on the size and physical area they cover. Local area networks. A local area network, LAN, spans a limited physical area. It is confined to a single building or a group of nearby buildings. LANs are used for sharing applications, printers, group scheduling, email, project tracking, and other tasks. LANs is shown in Fig. 1.57. Characteristics of LAN: spans a small physical area, uses high-speed wired/wireless connections between computers. It is a very reliable network. Communication errors are very rare. It consists of a limited number of computers. Wide area networks. A wide area network, WAN, spans a large physical area, connecting several sites of an organization across cities, countries, and continents. Because of the longer distances involved, WANs are sometimes referred to as long-haul networks. A WAN is often made up of two or more LANs connected together, as shown in Fig. 1.58. Characteristics of WAN. Spans a large physical area. It can be worldwide like Internet. Communication speed is slow compared to LAN. Connects computers through public networks, leased lines, or satellites. Connects multiple LANs. Sometimes communication errors occur due to its complexity. Metropolitan Area Network. Metropolitan Area Network, MAN, can span from several buildings or a large campus to entire cities. MAN is used by many organizations. It also connects a number of local area networks with high-speed communication lines. Characteristics of MAN. It is larger than a LAN and smaller than a WAN, covers an area of between 5 to 50 km diameter, provides high-speed communication, used by telephone companies, internet service providers, and cable TV companies. Virtual Private Network. Virtual Private Network, VPN, is a computer network that provides remote access to individuals and offices to their organization's networks. It provides cheap communication by using public telecommunication infrastructure, such as Internet, instead of expensive leased lines. It allows employees at home or on trip to connect their laptops into the computer as office through public telecommunication networks and do their work. Characteristics of VPN. It uses public networks such as Internet to connect computers. Provides secure remote access. Enables file sharing, video conferencing, and similar network services. Provides cheap communication over long distance. Network topologies. The arrangement of network nodes, any devices which are part of network, and connections between them, is called the network's topology. A node represents any device on the network. Topology is simply a map of the layout of nodes and connections in the network. 4 network topologies are popular today, namely bus, star, ring, and mesh. Bus topology. Bus network topology connects each node to the network along a single piece of cable called a bus. Bus network topology is shown in Fig. 1.61. Features of bus topology. Suitable for a small network. Easy to connect a computer or a peripheral device to the network. Requires less cable to implement. Terminator is installed at each end of the cable to prevent signals from reflecting back onto the bus and cause errors. Terminator is a device that is attached to ground. Limitations of bus topology. If the single cable is damaged or broken at any point, the entire network can go down. Difficult to identify the problem if the entire network goes down. Not suitable for large network. Star topology. In a star network topology, each network node is connected to a central device called a hub. Large networks can require many hubs, and hubs can be connected to each other to create a single large network. Star network topology is shown in Fig. 1.61. Features of star topology. It is suitable for both small and large networks. Easy to install and wire. Easy to detect and remove faults. Failure of cable does not stop the functioning of the entire network.
Limitations of star topology. Failure of the hub causes the entire network to go down. Expensive topology to implement. Lengthy cable with a hub is required to install star topology. Ring topology. Ring topology is shaped just like a ring. It is made up of an unbroken circle of network nodes. Ring network topology is shown in Fig. 1.63. Features of ring topology. Each node is directly connected to the ring. easy to install and wire. Data on the network flows in direction. Not costly to implement. Limitations of ring topology. If the ring is broken at any point, the entire network stops functioning, slower than other network topologies. Mesh topology. In mesh topology, each node is directly connected to all the nodes as shown in Fig. 1.64. Features of mesh topology. Most reliable network topology. Data can be routed around failed computers or busy ones. Can manage high traffic. Limitations of mesh topology. Most expensive topology to implement. Setup and maintenance is very difficult. Data communication standards. Data communication standards are a set of rules, protocols, and specifications that define how data is transmitted, received, and processed in computer networks and communication systems. These standards ensure that devices and systems from different manufacturers can communicate and work together flawlessly. Data communication standards play a crucial role in enabling interoperability, reliability, and efficiency in the exchange of data. The OSI Open Systems Interconnection is one such standard conceptual framework used in the field of computer networking to define and understand how different networking protocols and technologies interact and work together. Open Systems Interconnection, OSI Model. The International Standards Organization, ISO, based in Geneva, developed standards for international and national data communications. In the early 1970s, ISO developed a standard model of a data communication system and called it the Open Systems Interconnection, OSI Model. The OSI model consists of 7 layers. Each layer performs a specific task during data communication, as shown in Fig. 1.65. The 7 layers of OSI model are described below. Layer 7 Application Layer. Application layer provides services to end user. It interacts with the operating system or application software whenever the user wants to send files, read messages, or perform other network-related activities. Layer 6 Presentation Layer. Presentation layer takes the data provided by the application layer and converts it into a standard format that the other layers can understand. At the receiving end, it also formats the information so that it looks the way the user can understand. Layer 5 Session Layer. Session layer performs functions that enable 2 applications or 2 pieces of the same application to communicate across the network. It performs security, name recognition, logging, and other similar functions. It also establishes, maintains, and ends communication with the receiving computer. Layer 4 Transport Layer. Transport layer establishes connections between 2 computers on the network. It handles quality control by making sure that the data received is in the right format and the right order. Layer 3 Network Layer. Network layer decides which physical pathway the data should take to reach the destination. The communication device router works in network layer. Layer 2 Data Link Layer. Data link layer defines the format of data on the network. This layer converts the data into packets and checks them before putting them on the pathway. The communication device switch works in this layer. Layer 1 Physical Layer. Physical layer defines cables and signaling. It provides hardware, means such as cables and connectors for sending and receiving data. Cables, hubs, and repeaters work in this layer. Data communication protocols. Different communication protocols define how data is transmitted and received over a network. Examples include TCP/IP Transmission Control Protocol/Internet Protocol, used for Internet communication and provides reliable, connection-oriented data transfer. HTTP Hypertext Transfer Protocol, used for transferring web pages and related data on the World Wide Web. FTP File Transfer Protocol, used for transferring files between computers on a network. SMTP, Simple Mail Transfer Protocol, used for sending email messages. The Internet. The Internet is a global network of interconnected computer networks that allows for the exchange of data, information, and communication among users and devices across the world. It is a vast and decentralized network that spans continents and connects billions of computers, servers, and other devices. Evolution of the Internet. The Internet has evolved from its origins in the 1960s as ARPANETU's Department of Defense project for research institutions and military installations to become a global network of interconnected computer networks. In the 1970s, the development of TCP/IP protocols established the foundation for the modern Internet, allowing different networks to communicate. The 1990s saw the emergence of the World Wide Web and web browsers, revolutionizing how people access and share information over the Internet. The 2000s brought broadband internet and social media platforms, while the 2010s saw the rise of mobile internet and the Internet of Things, IoT. In the 2020s, the Internet continues to evolve with cloud computing, artificial intelligence, and 5G technology impacting nearly every aspect of modern life. Working of the Internet. The Internet is the largest computer network ever built. It globally connects billions of devices and networks. It operates through a decentralized architecture using packet switching technology. Data is divided into packets, which are routed through a network of interconnected routers and switches. Protocols like TCP/IP ensure data is packaged, addressed, and transmitted correctly. The domain name system, DNS, translates human-readable domain names into IP addresses. Content is hosted on servers, and data is transmitted as packets to and from these servers. As data travels through the network, it is encapsulated in headers at each layer of the OSI model, such as the IP and TCP headers. When the data reaches its destination, these headers are removed through a process called decapsulation. Security measures like encryption protect data during transmission. The Internet's interoperable design allows diverse devices and networks to communicate, making it a global information and communication platform. Advantages of the Internet. The main advantages of the Internet include global connectivity, enables communication and access to information worldwide. Vast information, provides a vast information resources and knowledge. Communication, facilitates real-time communication and collaboration. E-commerce, allows online shopping and digital transactions. Education, supports online learning and research. Business, enhances productivity and global reach. Entertainment, offers streaming, gaming, and social media. Innovation, promotes technological advancements and research. Disadvantages of the Internet. The main disadvantages of the Internet include privacy concerns, threats to personal data and online privacy, cybersecurity risks, vulnerability to hacking and cyber attacks, information overload, overwhelming amount of data and misinformation, digital addiction, excessive screen time and online dependency, digital divide, unequal access to the Internet worldwide, online harassment, cyberbullying and harassment issues, health concerns, physical and mental health impacts. Common applications of the Internet. Main applications of the Internet include communication, email, messaging, and video calls, information retrieval, web browsing, search engines, and online databases, e-commerce, online shopping, banking, and digital payments, social media, networking, content sharing, and social interaction, entertainment, streaming, online gaming, and multimedia content, education, online courses, research, and e-learning platforms, research and innovation, access to research materials and innovation platforms, business and work, remote work, collaboration, and e-commerce.
For more interesting tutorials, please subscribe, like, share, and comment. Thanks.